Hello everyone, welcome to our project show. I'm Cai Yi and my team members are Tanya Zhou and Miguel Estrada. Our project is about NFL result estimation using Markov chain. Our work consists of four parts. First, I'll introduce the background and project goals. Then I'll explain our estimation model. In the end, I'll compare our prediction results with betting house and the actual reality. First, introduction. We choose NFL as our design target. NFL consists of 32 teams from 4 divisions: East, West, South, and North. One NFL game can be considered as a random experiment. We choose New England Patriots as our objective to achieve the following goals. First, use Markov chain to analyze data for patterns and determine which can be used to build the model. Second, build a purely data-driven prediction formula to get the winning probability of New England Patriots. Third, prediction model is able to show a similar trend along with the real results. For our model, we considered all the variables that seem relevant to predict the result. However, we try to adapt these variables that the model could be used in an objective way, without interpretation of the user. Also, some other variables can be included in our defined four variables. So in the end, we take four variables into consideration: location, adversary, weather, and position on table. First, location. Giving a higher probability of winning to the local team, location is considered as one of the most important factors. The current season results related to location is presented on the left. On the right, to calculate the transition probability and draw the Markov chain, we use last 3 years from 2014 local data as our database. For example, if the team win in guest, the probability of win in local next game is 0.85. When we began to predict the future week's results, since the previous results and the location are definitive, we only need to use some of the transition probabilities in our Markov chain model. For example, to predict week 12, we have known New England Patriots play in guest, so there are only two possibilities: win guest to win guest, or win guest to lost guest. Variable adversary. We want to calculate the historical winning records when New England plays with others. The probability of win and lose presented in the table were based on the data from 2014 to 2016. For teams that are not on the table, the probabilities of New England win will be set as 50%. Third variable, weather. In our model, closed stadiums will be treated as a sunny day since the conditions are identical. Cold days and snowy days will be considered the same. As long as the temperature is below 0 Celsius degree, windy days will be considered as rainy days since they both make gaming conditions very complicated for both local and guest teams. The table above shows the statistics of our team in different weather conditions. The fourth variable is the positioning on table. The team will be assigned to the top of the table if the winning average is above 60%. The team will be assigned as middle if the winning average is between 30% to 60%. In all other cases, the team will be assigned as bottom. The left table shows the position data in season 2016. However, we have to transfer this data to winning probability based on historical data. Since New England Patriots winning average is always above 60%, so on the right table, we only show the winning probabilities of the team, given our team is in the top group. Considering all the variables defined before, we made our approach to predict the next game result using weighted probabilities. The weight for each variable is optimized by historical results. Considering our calculations, Any PW above 50% indicates that the team is going to win the next game. The last part of our project is performance analysis. We make a comparison of our model and the reality in the figure. 1 represents win, and 0 represents loss. From the above figure, we can see our model only predicted run in Buffalo from season 2016, and the model accuracy reaches 90%. Next, we make a comparison between our model and bwin, the famous betting house. Using the same rule, we can see from the figure above that bwin predicted the run in Houston, Buffalo, and Seattle. Their accuracy is only 70% right now in season 2016. Now the figure shows predicted winning probability from our model and bwin. From this, we can see when is the best timing to bet in the betting house. Given our model's accuracy is higher than bwin, so when the difference between two models are very big, that is a good time to bet on bwin. For example, the gambler can bet win in Houston according to our model and bet lose in Seattle, which may win more money. So that's all for our project. Thank you very much.